that we tend to, contractors and landscape architects tend to not look at microclimates, because they could put the whole house area on one zone. They'll put the north side of the house on one zone and the south side of the house on this exact same zone, and we know that those plants need different water, have different water requirements. So we still need to look at our microclimates and break up our zones into that. North side of the fence, south side of the fence, those kinds of things. Elevation change that we're dealing with on slopes. And then also whether we're going to go with a grid pattern or that looped pattern that we talked about earlier. Okay. I'm going to come back in on the slopes when we look at this here in a few minutes. And then I'm going to show you some pictures here of how it goes together. This is some turf applications. This has the inline tubing in underneath the grass. And the one on the left is a soccer field, and the one on the right is the common area on a homeowners association. This is a loamy soil, so the tubing is every 18 inches apart. Okay, the emitter is every 12 inches apart, and they went with a 0.4 GPH emitter. And so that's all being irrigated by subsurface on this product. The product's put down at about 4 to 6 inch depth in that application. Okay, so when we're looking at subsurface irrigation, some of the advantages as a designer you need to look at when you're doing a shrub bed. Do I put this on the surface or do I put it down below ground? Okay. On the surface, it's easier to put in, it's easier to install, it's less expensive to install for the contractor. But the problem is it becomes more vandal prone. People will see it, they'll have a chance to do what vandals do to irrigation systems when they're left on the surface. But we also find, and it's more expensive to put it below ground, but we also know that it's more efficient to irrigate by putting the tubing below ground. When we're going below ground, there's equipment out there that installs it for us, that makes it very inexpensive to install. Keep going the wrong way. Again, here's that one common area on the left of that one homeowners association, just a little bit larger picture. We have that slope out there, and then the one on the right where it narrows down, that's all on one zone, by the way, where this is a larger area, narrows down to that narrower area, and then we have all those utility boxes. That's an advantage with a drip, is it doesn't matter the size of the area, the application rates are still being applied at the same rate, so we can handle those different areas that we're looking at. Downtown Salt Lake, this is 4th South right here and about 400 West. But you can see on the right a lot of utility boxes that are in there. We know as designers we probably shouldn't put grass in that application, right? But for whatever reason they did. And so now we're left as designers to irrigate that area that we have to deal with. And if it was shrub beds, it wouldn't be quite so difficult. But because it is grass and we have all of those unique areas that would be interfering with our spray heads and stuff like that, it makes it very difficult to irrigate.
Just a real quick question. When you do subsurface type things, then you have hard water. Do they ever clog up?
No. The hard water, when we have the hard water in our water, the water, that it's calcium or salts in the water, and basically when it's in the water it's soluble. You can't see it, and the reason that the hard water builds up is from when it dries out, when it stops running. So by putting it, typically the drip is beneath fabric or beneath mulch, it always stays moist and those salts are building up in other applications. Okay. This is Redwood Road down in South Jordan, and again another great area that shouldn't be grass, but it is, and we have to irrigate it. This was originally designed with spray heads, and they had 48 zones. This is 1.5 miles long on both sides. They had 48 zones, so 48 valves out there irrigating this. And the contractor looked at it and wanted to change it over, and he put the drip in it. and he reduced it down to 6 zones. So he eliminated 42 zones, a lot of control wires. The cost of installation went way down. Okay, this is Kansas City. This is a very steep slope. It's about a 45-degree slope. The owner of this property has owned this building from, he built the building 30 years ago, and he's never been able to have grass on the slope, and he, because of the steepness of it and the clay, the spray head overhead irrigation would just run off, and he could never get the sod to establish. And so he converted it over last year to subsurface, and this was the effect that he had. He's able to have grass on his slope that he's never been able to have. That's facing due south, by the way. It's a very hot area. It was about 100 degrees there when that picture was taken, and it was really the only green grass in Kansas City last year. They had a major drought there. This is in Wichita. This is Bermuda grass. That's why it looks so brown. But this is all subsurface, this athletic field, and it was installed last year also. And it's just dormant right now. But the other advantage here, when you look at an athletic field, it's more expensive to install this than an overhead irrigation system. But one of the factors that they're looking at here is liability. Kids out playing soccer in the field, they don't have to worry about sliding into a head or something like that and causing some injuries. And so that's what they're looking at. There's actually a project in Salt Lake that's 11 acres that they're looking at going with subsurface instead of overhead, just for that reason.
Like sports fields and stuff, do you have problems with like aeration and stuff when they like want to aerate the ground?
Yeah, great question. So with the subsurface applications, the tubing's down at 6 inches depth, and so when it's irrigating, we're getting a wetter soil profile down deeper than we would with overhead irrigation. And because of that, that water is mechanically opening up those soil particles, and so the need to aerate is reduced. But when we have an athletic field, like between the hash marks, we have physical compaction in there. And so is what they need to know is that my tubing's down at 6 inches. I'm not going to use an aeration device that will go down below 6 inches. They're going to use a 4-inch device or something like that. Okay. But great question. That's one of the things that the maintenance people need to understand is how it's being irrigated. This is in Denver, piece of grass. This is about 12 foot wide, and it's about 3 miles long on both sides that they're irrigating that grass. And then bunkers on golf courses. You know, it's always amazing. People find applications for it, but it's very difficult to irrigate bunkers. They don't like to throw water over the top of them because then it washes all the sand down into the bottom of them, and they irrigate every night, and then they got to come back every day and spread that sand around. So in this application here, they put subsurface on this piece, whatever you want to call it, and then it's out around about 8 feet all the way around it, and then they can keep their gear drive rotors not throwing over the top of the sand. Costs. Basically, is what we find from a cost standpoint is that subsurface is less expensive to install than a spray head and more expensive to install than a rotor. So wherever you would use a spray head, it's going to be less expensive, and wherever you'd use a rotor, like an athletic field or a golf course, it would be obviously more expensive. But there typically are other factors that they're looking at instead of that water savings. As there's a big push to use reclaimed water now, you can't throw reclaimed water in the air, so they're having to use drip to use that reclaimed water. So as designers, that's one of the things that you're running into in practice, is that you're being saddled with reclaimed water that you're having to use for your projects, and you can't throw it in the air. That's a huge trend that's going on right now. It has been going on for the last 4 or 5 years. So we talk about water savings. This is a project over in Colorado. Do we have any people from Colorado in here by chance? No? All right, just thought I'd ask. This is in Castle Rock, and this is a very restrictive area for water consumption. They're all on wells. and they know to the gallon how much water they have for the year that people can use for consumption for their homes, and then what they have available for their landscape. And so they restrict it it's very tight. And basically is what this is showing is some medians that go through a homeowners association, and there's 8 or 9 different taps, and then this is the flow rate for each tap that out there. And basically from 2000 to 2007, their average water use was 2 million gallons of water per year, and they converted it over to inline drip, and in their first year their water consumption was 855,000 gallons. So that's a 58% water reduction. And when you take and you convert that over to the cost of that water, in their first year they saved $17,500 in just water. And this is a pretty small median that they converted. They had the exact same amount of water savings last year. So in 2 years, they've saved $35,000. It's paid for the system in 2 years. So again, a very real world application of what we're looking at. Granted, these medians had grass in them, a lot of ornamental plants that probably shouldn't have been there from a design standpoint. Okay, that's something that we need to think about as designers. But again, we get stuck with certain restrictions and things that we've got to deal with. And so we have to look at other means of trying to solve those applications. So here's a picture of how, it's a series of pictures on this guy who installed this 1 acre project. And this is one method, so it's kind of almost like a time lapse. It's kind of cool to see how it works. So this is a 1 acre park. This was in 2002, and the brown spots are not from any fishing irrigation, it's actually from use. These have overhead irrigation rotors irrigating this area, and there was a major drought in 2002 in Colorado, and so they were looking at ways to conserve water. So what they did is they ripped this out and put in the inline irrigation system. So what they did is they killed the grass and rototilled everything up, and then they pulled out I might turn off this light. Is there a way to turn off this light? So what they did is they pulled out about 4.5 inches of dirt, set it off to the side, and then they laid out the tubing. Okay, so now you can kind of see we've got a small arc here and an arc going in a different direction. The tubing, the inline tubing, can fit our odd shapes very well. And so this is kind of an example of that. This tubing here is about every 18 inches apart in the soil. Then they came back in and put the dirt on top of the tubing. They used grade stakes so that they could have a consistent amount of dirt over the top of them. You can see the grade stakes out there so that they would get that. Okay, the next picture you're going to see is the exact same park. Okay, that first picture that I showed you was the park installed 3 years after the overhead irrigation system was used. The next picture you're going to see was 3 years after the subsurface was installed, and it was using 70% less water. Oh, why is it doing that? Okay. If I do it enough, you can see it. But it's very green. The grass is very thick. It's very green, and they're using 70% less water. That project right there is this Parks District. They are in year 12 of converting all of their athletic fields to subsurface because of that right there, that one project. This is their second project that they did, and they used the exact same method on a larger scale. And basically they took the tubing and laid it all out, and then they brought dirt over the top of it and got it at a consistent depth, and then they sodded it. And here's the sod application. This is 7 acres, and this is July, and it's 100 degrees out there, and they just laid the sod, and they're growing that sod in with the subsurface. So those were the first two projects. The next projects, they used these machines that would pull in the tubing, and it became very efficient for them, and it reduced their installation costs significantly. And then here's the 5-line puller that's pulling in 5 lines at a time, so it can cover a pretty good area. Okay. Here's some existing sod that they pull into. This is probably April when they installed it, and then it greens up after they installed it. A little bit larger area where they pulled it into an existing sod area. And then Redwood Road where they had that application too. Okay. So the maintenance, when we talk about maintenance on the systems, there is very little maintenance. According to CIT, on drip irrigation, maintenance is reduced by 80% when you use drip over overhead irrigation. And basically is what you're going to have is you have filters on the system that you're going to be cleaning periodically. And that's really about all of the maintenance that you're going to be dealing with. As tubing gets cut into, you'll go out and repair that, but other than that, there's no maintenance. There's no heads to replace, no nozzles to deal with, or vandalism that you really have to deal with.
So,
Yeah.
so say someone does, stick a shovel in your grass and
Yep.
fix your tubing.
Yeah.
Can you just go on to either side and replace that section, or how do you
Yeah.
fix that?
So if we think about this room as being grass or a large shrub bed, and we got the tubing every 18 inches in this room, and they decide to come out and plant a plant in somewhere in the landscape, we know that when they dig down in there that they're going to cut the tubing. And so if we have that grid, the advantage is because it's all connected, we have this looped system, okay, that the water is going to be coming in from all directions on there. So when we cut the tubing in this area right here, water is going to be coming from both directions in that tubing. All of the emitters are going to continue to work because remember, they only need 6 psi to operate. And so is what happens for the contractor to repair that is he's going to turn the valve on and water will come out those tubes. And as what he's going to do is he's just going to take an insert coupler, and I'll show you how, we'll go over this here in a few minutes. He's just basically going to put an insert coupler and connect a piece of tubing over to the other one and connect it in there, and he's done. And then cover it back up with dirt. So it's very easy to repair. I'll show you how we do that. But it's very simple repair. Most contractors, when they think of this and they see all of that tubing out there, they get really nervous because there's a lot of tubing out there. There's a lot of places to get cut, and it's true, there is. But when you really think about it, when you go out and you cut it, you know exactly where the tubing's at. Just turn on the valve and the water comes out the tubes, and just connect the two together with a coupler and an extra piece of tubing, and you're done. It's very simple. The mistake a lot of people will make is that they'll just cap it, and the problem with capping it is if they cut the tubing on that exact same line down to the straight, no water will be flowing in between those tubings in between the trees. So the repair is pretty easy. Okay, why don't we take a break? 9:30. You guys have a lot of donuts to eat. We'll eat some donuts for a few minutes, and then we'll come up with some real-world design applications and have you guys do some calculations. Fair enough?